All right, guys, today we got the same title as yesterday, except it's part two. Part two of more double angle, half angle, product of sum formulas. So we're going to start with the product of sum today, and there they are. And of course, we'll put this on your paper for you. You'll have that, and we'll just use that. So let's try one here. It says express sine 3x times sine 5x as a sum of trigonometric functions. So looking at those identities from the last page, that's sine times sine. Whenever you do sine times sine, we're going to work it out like this. We're going to say 1/2 times cosine of u minus v, which in this case would be 3x minus 5x. And then we're going to do minus cosine of u plus v, which would be 3x plus 5x. And that's going to give us, when we work it all the way out, 1/2 cosine 2x minus 1/2 cosine 8x. So we're going to leave it at that. Okay, so just rewriting something from a product into a sum using our product to sum formula. All right, sum to product, going backwards. Now they're having things like you add two sines, or you subtract two sines, or you add two cosines, and you subtract two cosines. And these are the formulas that we're going to use in order to do that. Okay, so again, let's try one of those. All right, this one says write sine 7x plus sine 3x as a product. So I'm going to follow just what we did on the last page, what you saw, and it would look like this. 2 times sine of 7x plus 3x over 2. And I'm just following exactly one of those formulas. I know I didn't write it down here, but it was on the last slide, and it'll also be in your identity page, over 2. All right, so it gives me, if I work all that out, I get 2 sine 5x cosine 2x. And we're just going to stop right there because it's a product. So we just took a sum, made it a product, and it was fun. All right, this one says write sine 2 inverse cosine -1 as an algebraic expression in x only. All right, so I'm going to start with this inside part right here where it says where's inverse cosine of x, which is really saying where's cosine x. So cosine is x where the adjacent side is x and the hypotenuse is 1, which means this side over here is 1 minus x squared, square root of 1 minus x squared. That's just using Pythagorean theorem. Okay, so I'm looking at this, like it's sine 2x, where the x is the inverse cosine. Okay, so I'm thinking that formula for sine 2x is 2 sine x cosine x. Okay, so sine x I know is opposite over hypotenuse, which is the square root of 1 minus x squared. Cosine x is just x. So all I can do there is multiply what I can, and I get this right here, 2x on the square root of 1 minus x squared. Okay, so is that expression with just x's only, which is what we have right there. All right, evaluate sine 2x, where that's supposed to say cosine. That says, I forgot the s. Cosine x is -2/5, so it's x in quadrant 2. Now, if you're going to work out sine 2x, you must also have cosine and sine. You got to have both. So if cosine is 2/5, that means I can do 2/5 squared plus sine squared equals 1 to figure out what the world sine is. So if I square 2/5, that's 4/25. And if I move 4/25 over here with the 1, be 1 minus 4/25, so it should be 21/25. Take the square root of both sides, and you would get plus or minus the square root of 21 over 5. And because it says we're in quadrant 2, sine is positive in quadrant 2, so my sine value is going to be square root of 21 over 5. Now, again, sine 2x. Sine 2x is, from your sheet, from your identity formula page, 2 sine x cosine x. All right, so I'm just going to work that out. Now, since I know what both sine and cosine are, I can just do 2 times sine x, which is square root of 21 over 5, times cosine, which is -2 over 5. And I'm just going to multiply that out, and I would get -4 on 21 over 25. That's all you got to do there. One more thing here. We're going to prove an identity using some of these great formulas that we have now to work with, and we're going to prove that sine 3x minus sine x over cosine 3x plus cosine x is really just tangent x. Okay, so what I have on top here, my numerator, I have sine subtraction. So I'm going to use the sum to product. When I do that, I get 2 times cosine 3x plus x over 2 times sine of 3x minus x over 2. All that's over. Down here I have cosine addition. So I'm going to follow that formula, and I will have 2 cosine 3x plus x over 2, which looks familiar on the top right there. And also cosine, I'm just reading the sheet, 3x minus x over 2. Okay, so when I work that out, on my numerator, I have 2 cosine, that's really 4x over 2, which is just 2x. The sine is going to be 2x over 2, which is just 1x. My denominator, I have 2 cosine, that's 4x, that's 2x, and sine of x, sorry, that's not sine, that's cosine. Sorry about that. Cosine x. And what happens is the 2's cancel, the cosine 2x's cancel. It leaves me with the sine x over cosine x. And guess what that is? You guessed it. It's tangent x. So we did it. We got there. We proved it. We're awesome. And that's that. Okay. Gosh, my chair's always squeaky today. Hope you don't hear that on the video. We'll see you tomorrow. We'll work on a bunch more of these. Can't wait to see you.